Hey, it looks like we're live. Welcome back. I'm going to be continuing to work on my virtual machine. I will place that in the chat. Okay, so last time we wrote out the Fibonacci assembly, and then it didn't work. So the main reason, there was a couple different reasons, but the main one that did not work was in here. So when we were calculating the program size, we were doing things all wrong, but now it is working basically. That's basically we're calculating it in here, and then we're returning the program size, and we're setting it here. So when we write it, that will work. And then we read it, and we get the program size properly. So I did one more change. So you can build everything, and that's cool. And it builds these. But then you can also do passive flag -t, and that will build every test in the test folder. So if I run that, yeah, there we go. I just have the one right now, the Fibonacci one. So I will show that in a moment. But yeah, so it's just a build script. Yeah, that's how it works basically. Yeah, so we can run it. Now it takes a file name, and it will actually generate the proper file name. So let me actually remove that one that I built, so I can show. So if we run TASM, we run it on testfib.tasm, then there we go, and it will generate it with the proper name. So now let's go ahead and emulate it. So run Timmy, and we will run fib.tim, and there we go. So it goes forever. What we can do is we can pipe that into head and then give it a limit. So like 10, these are the first 10 Fibonacci numbers. Yeah, 20, 30, and it starts getting pretty large. But yeah, it does actually work. So that's pretty cool. I actually wrote it correctly first try. It just didn't work because of the problems with the emulator. But yeah, it does indeed work. This is it. Yeah. For anyone who is wondering. That actually might not work. Or it still should work. Let me make sure it works. Because we have the jumps, which jump to a specific index. It should still work though. Test fib.tim. And yeah, okay, so it does still work. Okay, so today I would like to be adding labels. So, oops, I didn't mean to do that. Alright, let me remove that .tim file. So let's see, labels, label example. What is label test? .tasm. Alright, so basically we'll have something like jump main. This is how you define a label. You type the label name followed by a colon. And then, yeah, you can just type whatever you want in here. +5, add, and so we could do something like that. And then that should jump to main, right? So you could do this where you have jump, then it just jumps to the index, which is 0, 1, and 2. And that's what it will actually compile to when we compile it. But it's much easier to do it like this, and then also it allows you to move stuff around and you don't have to update it. That's what we need to do. So let's actually just see what happens if we try to run this on test/label test. I'll just call it label actually. I'll change it. Yeah. Custom identifiers are not implemented yet. So we know exactly where we need to go. So it is tasmlexi.c 192. There we go. So this is what we need to do. So so if type equals type none, then the type will just be a label. So let's see, and type equals label, or let's see, type label, and there we go. Yeah, so now we just have to add that type to the .h file. So .h. So I'll put it down here before the halt. Type label. So actually, I'm thinking that I should probably do something a little bit different. So we should have label declaration, and then just type label. So if we have the declaration, that is when it is followed by a colon. Otherwise, it is just a regular label. So we do need to detect that. So let's actually just, if type equals none, then we'll do token type, yeah, we'll just do type equals generate, or get label type. Get label type. And yeah, we will pass keyword name. And also we are going to need current and current index. So actually I didn't need to do that. Yeah, because we are going to need to go to the next character, check if it is check if it's a colon, and then we can set the type based on that. So let's actually declare this function. Yeah. So here is this. We'll put it right under there. So this will return a token type. Yeah. Token type. Let's check label type. That's what I'll call it actually. So yeah, it will take keyword name, current, and current index. Okay, so check label type. Yeah. So basically, we have that now. So we can do current index. Yeah, we need to do it. I think this will work. I'll do it differently. Current index plus equals 1. If current index equals a colon, then we will return type label def. Yeah, def. Actually, I'll change it to def because I think it's better. Because definition of label, right? Else, which we don't even need else because we're returning there. Then we can just return. Well, actually, let's do current index minus equals 1 because that means we went out of bounds, or out of, yeah, the bounds. And then we can just return type label. So I'm pretty sure that should work. So let's try to build that. And we do have some problems. Unused parameter keyword name. So yeah, we don't actually need to. Yeah, we don't need to pass that actually. We just need the current ones. That is up here. Alright, build that. So, yep, we need to go ahead and do that. And also we need to dereference that. Okay, so now that is not handling the switch, so we need to fix that. So in generate instructions, that is actually in the TASM.c. So let's just add that really quick. So yeah, down here. So we have type label def. Yeah, type. All right, so these in the actual emulator, we aren't going to encounter it, but we might encounter it here. I think we're gonna handle it in the parser. I think that makes sense. Yeah, so in the parser we'll handle it. So it should not be labeled, yeah. And then this should not be, or it should not be labeled. Alright, yeah. So I think we can do that. Now if we build it, so let's actually check to make sure it does work. We can actually do that right down here. So I have it set up for debug purposes. Alright, so let's run TASM test / label test. Alright. So I think we do need to handle that in the print token. That is a good idea. Yeah, so because I have a default in here, it doesn't actually give us a warning. Alright, type label def, type label. Type label and label def. Alright, so that should work now. False and unreachable. Alright, so that is in the parser. So that's okay. We got the label. We just got 2 label types. So that's not what we want actually. We want one of them to be a label def. So we did do something wrong. So let me see. Actually, it's gonna be down here. This is the problem. Actually, we're just setting the type equal to label. So we should be able to do that now. And now we have. All right, it's still both type labels, so that's not good. So let's print current character is current index, and we'll see what it says. So if we current character is none, so it's a new line. It looks like actually. Let's see. If I open up the let's see. That's not gonna work actually. Let me open a new one. Let's go into test, and we'll open label test. So yeah, this should be correct. So something is not right. Whoops. All right. Let's see. What is not correct? You know what? It is actually already on that, so we don't need to do current index plus plus. Yep, there we go. Because I forget that it goes one past where we need to be. So yeah. So that should be everything fixed. Label that. Yeah. All right. So now we have labels. And it does have the proper text on it. So I'm thinking we're gonna use a hash map for this. So let me see if I can find it. I'm not gonna implement my own right now. I do have this one that I use in a different project. Right here. I can put that in the chat. It's very good. It is a good one, and it works on basically any data type. So I think I'll just implement this. So if we just grab this raw, and then I can just put that here. All right, and now we have it. So in the parser, let me open up a parser actually. So what we're gonna do is we're gonna go through it, and if we encounter, all right, we're gonna have to modify this. All right, label def. So if we encounter a label definition, then we are going to add it to the we're going to add the index of it. Yeah, we'll add the index of it to the hash map. And the key will be the text of it, so main in this case. And then the value will be its index, and we will just push it as a type note. Because then we'll just skip past it, but it will keep the index there. Type note. So yeah, so let's actually look at this. So we can declare, yeah, just create a hash map, just like this. If I copy this, or yeah, all right, we will. I think we can create it globally. Should we do that? Maybe that's not a good idea. Maybe it's not. Yeah, we can just pass. It's just one function. So we'll just, whoops. So right up here, we'll do const unsigned initial size equals 2. All right, that's fine. Hash map. And we'll call this label hash map. Label map. And then if label, or yeah, hash map create initial size, and we'll pass the label map, does not equal 0. Then we are going to printf st there. Error could not initialize hash map. And we will exit with a 1. And then if it does work, yeah, so we just need a simple one. Then we can put stuff in the hash map. So we'll want to pass the hash map into here. Hash map. Yeah. So we need to accept a struct hash map s. Struct hash map s, and we'll call it hash map. So when we encounter one of these labeled F, yeah. So we will do if hash map put hash map, and then yeah, so we are gonna put lexer token stack index dot line, and then also the sterling of that line, because we need a length. And then let's see, what else do we put? And we have to pass, okay, so that's the key. So actually, no, we want this to be the value. So yeah, we have to change this a little. We will pass token stack index dot value, I think is what it's called, and we'll pass the sterling of that. Token stack index dot, and then we can pass the vector token stack index dot line. So if that does not equal 0, then error could not place in the attachment. And we'll just put extra. Probably makes sense to separate this out into its own variable. Dot. And we'll exit with 1. Okay. And then yeah, so we'll append it. So now that should be in the hash map. And then here we will just assert false, not implemented yet. And new line. Alright, so let's actually try to do this. Alright, so we have some problems. Unused variable. Alright, so I must have, yeah, I put the wrong name here. It is a label map. Alright, unused variable. Oh, okay, so we need to actually modify the header. Whoops, parser.h, and we need to change this to accept a struct. No, I didn't actually include that either. So actually, there we go. Alright, yeah, so let me include that in here. Include hashmap.h. Alright, now so I also messed up fprintf. It's on line 147. Printf. Whoops. So there we go. So yeah, I forgot, I messed it up apparently. This needs to be that. Alright. So yeah, we need to pass an entire token. So just doing a type nope will not work. We can do dot type equals that. There we go. And I think that'll work. Okay, does not work. So we gotta create a token. Token equals now size of token. And then we'll do token of type equals type nope. And we'll just pass that in here. Alright, we need to pass it as a pointer. Okay, oh, alright, this needs to be actually nullable. So we'll just do something like this. Okay, Token has no member value. So what is it called then? We have this here. So text, that's what it's called. So we want this to be text. Text and text. Okay. Da, 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 da. All right, so we need to actually all right, let's create int let's see, int line num equals flexor token that index dot line, and we will just pass that in here. Line, yeah. Okay. Unused parameter hash map. It's used right here, but I messed something up, so I forgot that's in phone. All right. Mm-hmm. 15. Okay. Um. I think that'll work. So. Mm-hmm. Why is it conflicting types? Oh. Is it S or H? Let's see. It's S. Yes. Okay, so that is the issue. There we go. Alright, so now let's see. We can print the list at the end. Text. Alright, not implemented yet. Let's actually just do nothing. Alright, then we segfault, so that's not good. Alright, well, let's try to implement this now. So we can do a similar thing. So yeah, let's actually look at getting from a hash map. Alright, so if we do int kata followed, thank you very much. I appreciate that. So yeah, int fonts element equals hash map. I don't know if we'll be able to use an int or if we'll have to change style. And then yeah, so we need to pass the value of the current token. And I'll add check-in as well for when we if you try to reference one that it does not exist, or if you try to redeclare it, but I'm just trying to get it working normal first. That should be fairly easy to do though, once it is working. Dot text, and then the strlen of that. Dot text. Okay. So it's actually for removing. What was get? Yeah, it's the same thing. So then if it is null, element equals null, then error undeclared label. Right, so 1. Otherwise, we are going to append this, and we'll actually set the let's see. So we need to create a token. Token equals that, and then the oops. So it'll be a type of int. Token token dot type equals type int, and token dot value equals it equals the element. Which let's actually change that to label index. I think that is a bit more clear what it is. Alright, so this needs to be a pointer like this, I think. And then, yeah, we need to do something like that. Alright, and let's see. Token has no member. Alright, so token dot text. So we also do want to pass the line number and such. That would be a good idea. So assignment from character. Alright, alright, so perhaps this should be a string. Let's do token.text, and then label index. Right, previous definition of token. Okay. So yeah, let's actually modify the token directly. So the lexer token stack index dot type equals type int, instead of doing this, and then yeah. And we'll do the same thing, lexer token stack index. Actually here we have to do it down here. Lexer token stack index text is that, and yeah, we'll pass this. Alright, let's see, but it is a, oh yeah, so I did not provide that. Okay, there we go. So let's actually do the same thing up here, where we modify this. Then we don't have to reset everything. Yeah, so we want the type to be nope. Nope. See, I don't know why I'm doing that actually. Okay, so that we don't need this. Okay, whoops. All right, and let's see. So now we have a problem because I need to. Where did I use token? 125. Okay, so I just forgot to do this. Token stack index. There we go. Label index undeclared. So yeah, this needs to go down here. Alright, so let's try to run that. And undeclared label main. So it didn't work. Because I just completely forgot, we have to actually wait to do all this. Till after we iterate through. Then we'll go through one more time and check the labels. So yeah. So actually let's just let's see, I think we can do something like that. So yeah, then it goes through all of them, and it should have modified correctly the label. Let's see. So yeah, now if we just traverse through the list, and whenever we encounter one of these, a type label, then we'll just do all this stuff. So I completely forgot that I'm supposed to be doing that. So let's do void check labels, and we will take the should we take the we'll take the root node, which is a parse list root. Object to it, and we will just do while root does not equal null, and we will go through, and we'll do root equals root next, and we'll call this head instead of root because that's a much better name for it. All right. So if head token dot token stack, we'll need an index as well. Int stack index 0. We'll do stack index plus plus. So if that at the stack index dot type equals type label. So actually we do want to append that here. Let's see. So up here we will do append this. Just like that. Just how it is. But then we are going to want to grab all of these things and put them in there. And if we go up here, we can get rid of this continue. So now, so it should work. Request for token stack. Let's see. So I seem to have messed something up. Right. Let's see what happened. So, so I don't actually recall this. That is one thing. Let's see. So yeah. Parse list has no. All right. So what is in the parse list? Value. Okay. So it's just called value. That's kind of a weird name, but okay. I'm the one who named it, so. So value. So this isn't actually this isn't right. It is head value dot that. Head value dot token stack head value dot token stack. And yeah, so this actually we don't need to append anything because we're just modifying it directly. Head value dot token stack. Let's make sure that's all of them. Okay, so let's try that now. Alright, so it is not because I missed this one. Head value dot token stack. Alright. So token. Is that what we need to do? That might be it. Let's see. The token doesn't have. Yeah, that's in the lexer. So. Okay. So yeah, this isn't what we need to do actually. We need to get it directly from the token, from the value. So we don't need the token stack. Yeah, we don't actually need that at all. Because it is directly in there. I forgot. That's how we're storing. So should be able to just get rid of all this. Which I could do like a search and replace, but I'm not gonna do that. Okay, alright, and we can get rid of the stack index actually, because we're not using that anymore. Alright, and now we just have hash map undeclared. So we need to pass the hash map as well. So it is hash map or struct hash map as hash map. and we'll pass that. We're not calling it yet, so there we go. So we need to call it after we generate the list. Yeah, so we will do check labels. Well, it's really more like generating labels, but and we will pass the root as well as the label map. Right, and we'll run it. Okay, so let's see. So is this the list that we're printing? I need to go into the right here, and we don't want to print these anymore. So run that again. So did it not modify them properly? Let's see. Okay. Oh wait, oh okay, so it did work actually. I just was reading it wrong. Because we have jump to an int, which is 6, and if we look actually at the assembly, which we have open in here, label test dot hasm in here 0 1 2 3 4 5. So actually we need to do -1 because it is 0 index instead of, yeah, so it is actually -1, so we have to do that. -1. Okay, now let's run it, and it should be 5. Okay, so I think it should work now actually. Assuming nothing is wrong, we run it. Label test dot tim stack underflow. So something is wrong. Let's see. Okay. Yeah, I'll close out of this. Let's open this. So why would it underflow? So are we doing something wrong in the jump? We can actually take a look at that. So just the regular jump. Yeah. Yeah, so let's see, stack. Oh, yeah. So is that the error message that we are getting actually? Stack underflow. So it is right here. So why are we popping? So get rid of that. We'll run hasm again. Hasm. Alright, it doesn't print anything. That's not good. You know what, the jump, we might actually want to set it to the lineup. Now that I'm thinking. So I think we do handle that. So let me try that. So in here, we don't do -1, we do that. Now if we build it, slash hasm slash label test dot hasm. Label test dot tim. It still doesn't print anything. But now I think that it won't overflow or underflow. Yeah, so I'm not sure why it's not printing though. So, because the printing works with the fib, let's make sure that still works actually. Yeah, so that is still working. And the print works in there. So it is something wrong with the program. So let's actually let us print the stack on each iteration. This is the wrong place to be doing that. In here. Da, da, da. Here we will print stack machine, and if we build it now, alright, label test on test. Alright, and if we run it, so yeah. So why does it? Oh yeah, because that's for each token. It goes through these iterations. So it never pushes anything to the stack. Could it be because of the indentation? I don't think so. Yeah, because it actually was working properly, so that's not what it is. If we get rid of that, then we're gonna get an error. Yeah, undeclared label. So that works. But if we do this, it doesn't work anymore. Should not be labeled that. That is in here. So it's because we should handle that in the parser though. Oh, that's the wrong one. So why? Oh, because it never gets converted into a nope instruction. So, well, no, it should because we encounter it here. So I'm not sure why that would be. Label that. Alright, and let's see if we can see that. So we never encounter this. Right, we can get rid of that current character actually in the lexicon. Yeah, look at that. But, so we should not be. So I'm not sure why that would be happening. Because we go through them all. Because it's clearly a type labeled up here. Let's search. Stack. Index. So let's try doing that. And then we can not print the list here. So yeah, when we get. So it just stops after the add. Wait, because that's where we stop. Yeah. It just doesn't work with that. But that should be the root node. So let's see. So yeah, we get a label. Oh, okay. Yeah, that is why. So because we set this equal to, yeah, we set it initially. That's why it's not working. Okay, okay, I know what's happening now. So we're gonna need to change this. So because our append, it only works on that. So we might need to change this. So right now we are going through and then we're checking. Yeah. So let's do actually if equals null, then we can do temp equals next. Else we will do this. So then that should detect if it's the first element. So then we want to change this and we want to get rid of this assert. And we want to just set the next equal to null here. So let's see now. Have some problem. Next is undeclared. It's new. Alright, now let's see. Now first one is nope. Yeah, so it didn't work actually. Alright, well we can just actually do equals null. You know what? Actually, it'll work if we change this to be so we can actually do if we check up here equals null, then we can do all of this. So actually we can do this at the top regardless. Then if before the loop it equals null, then we do that. Otherwise we go through the loop. So let's do that. And we can get rid of this right here. And then yeah, so let's see. So that now it still did not work. Okay. So that is I don't think we need to set this. We can just do if or we start it out as null. Yes, that doesn't work. Yeah, then it starts out as add, so that's not what we want. You know what? Actually, yeah. Okay. It might be working now. Actually, no, because that's still on an int. Shoot. No, but it could be an int if we do this. And want to actually not print it up here. So get rid of print token. So then we just have one, which is add. So that's not what we want. Root equals next equals next. So now it is not working at all. Okay, Hmm. Let's actually. Let's see. So what is? Let's look at what we have. So yeah, we can print that text. And we need to. Okay, so the value is just no. Hmm. So yeah, so that is working. Hmm. Okay. So the head is never actually properly initialized. Okay. Stack 0. Yeah, so it works when we do that. I just do dot value equals that. So then it doesn't work again. Uh-huh. So actually, let's just let's see. Let's separate this out into a different function. Void handle open depth. Alright, so let me do that and paste it in there. So we need the lexer. What else do we need? We need the hash map. And I think that is it. So yeah. Then if we do handle token depth down here, handle token depth, and we'll just pass the lexer and the hash map. And we can get rid of all of this. And that should work. Oh, and we need to pass the index as well. So yeah, in here, index. All right, so now we can just call this down here, and index can be 0. But yeah, we don't want to call that all the time. Just if it is, let's see. All right, so I will change it. And it's called a label map. So, all right, should not be label. So it still didn't work. Okay. We don't actually append that. well, yeah, we did this before. Yeah. So, all right, it didn't work then. So if flexor dot token stack 0 equals type token def, and do that, then that messes it up. Something. Yeah, label that. All right, and that puts on. Yeah, dot type. So then it becomes type no. But if the first one is that, then we segmentation fault. Because it broke from on the hash map. Okay. Let me do actually. Let me see if I can fix the append. Because I'm doing it not right. Alright. So it is null. Then that happens. Okay. So that's pretty similar to what I'm doing actually. So click push. And then it's a push after. So we get that one twice. Because of this. Alright, so now it seems to be working. So it's hit type in. Okay, so we just had a problem with that. So yes, let's look at that. Alright, so 10 is on the stack. So let me not print the stack on each iteration anymore, because that gets a bit confusing. Test slash label test dot 15. Okay, so yeah, so that works. Test slash label test dot 10. And okay. Doesn't work anymore. So why is it okay. What happened? It was just working. Let me undo. So it works like this though? No. But if we push 5 there, then it does work? No. It was just working, I swear. Undeclared label E. There is no E. Because we're in the wrong one. Okay. So now it works. If I get rid of this, does it work? Okay. So alright, so that is working now. Alright, so that is a stack on the floor. That is correct. Okay, so if we add it and then can we print? Okay, 20. That is right. So let's see if we can jump main. And then if we do push 5, then, or let's do push 2, then it shouldn't work. And it goes forever. So what is the value of the integer? 0. It should be 4 though. Okay, so something is not working in the parser. Alright, so let's look at this. So it jumps, so why is it 0? And label index, and let's see what it is. Zero. So why? All right, let's take this now and let's put it up here as well. In here, and we'll print the what? And let's actually add that so we know what it's at. Yeah, but it is that 4. So I must be doing something incorrectly. Okay. So it should be working. Because this should be the same token. Jump main. And if I change this to something undeclared, it should say that. Okay, what segmentation fault? So, oh, that's because I'm trying to print it properly. Yeah, so it is just setting it to the wrong value. Because if we set it to 4 minimum, then it is 4, and then we can run it. Let me get a stack underflow, because we want to actually jump to 3. There you go, 20. Yeah, so that is what we want it to be. So it is not translating that properly. So let's actually remove it. All right, so let's try in here. Oops. So let me move this around. All right, so I don't think it will cause an error, but we should be able to see if it works. Print F. Okay. Don't need to do that though. And we don't want it to be X. We want it to be xer token stack index dot x, and the same thing here. Okay, did it print removed? It did. So that means, actually that means it wasn't removed, because, yeah, so it did not remove that one. So that's not the problem. And when we print it there, Y number is correct. Let's see, does it need to be a constant? Alright, actually, that. Alright. Okay. So that actually doesn't help. So what can we do to make it work? Let's try to actually get the element. Let's see. Get hash map. Right here. And then if element. Actually, I think we can just print the element then. And we'll see what the value is. Alright, that doesn't work. I messed something up. You know what? I am probably, yeah, I'm missing a program proceeds. Alright. So yeah, I need to dereference this. So let's see now. Yeah, so it prints 4. This is not the right number at all now. That is way out of bounds. It's actually not. Okay. So when we get the element, it is correct. But then it is not when we get it afterward. Huh. So let me go up here actually and change this to if it equals 0, then error re-declaration of label depth, and we'll put the label text. So why is it 0? Mixer stack index dot yeah, the text. Yeah, so it's main actually. So that, I'm not sure. It's just not updating in the hash map. So it must be. Okay, head is not clear. Yeah. It is mixer token stack index. Yeah, so it's but then that does. What if you try to get it twice? It's not gonna work with this constant actually. So let's just make a new one. Label index 2. And we'll print that right after. Alright, yeah, so that works. Can this just not be const? Hmm. That doesn't work. It's something like this. Alright, so it's like it doesn't work. Because that all works. And it lets us grab it multiple times. Hmm. Huh. So what if we try to jump after? That's gonna cause a loop, but so yeah, now it sets it to that again. So it doesn't work like that either, it seems. Yeah, and it's 0. Um, okay. Okay. So that worked. So yeah, it is just a scope problem. That seems to be what it was. Yeah. Okay. So if we move this back up here, then it should work. Okay. Okay. Let's see. Man, I was stuck on that. I get stuck on the stupidest things. Stack underflow. Okay. So is it jumping one too far? Yes. Because we need to subtract actually. Because we don't do that. Yeah. Right. That doesn't work. Why no something there? Okay. So now can I jump out of bounds? So what did it set it to? Yeah, because we actually subtracted. Yeah, we need to do like this. Something like that, I think it should work. No. Yeah. Alright, so that won't work actually. So, if we just do one num equals size of int, and then we do line num equals that. That's 1. And we pass it in there now. Alright, now when we run it, and yeah, okay. Dot 10. Alright, so it is still 10 because of that, but we redo it, 20. Okay, so it seems to be working. So we seem to be jumping to the right place. So we should be able to declare another another label up here, like again, and that will push 5, and then we can jump to, well, here we have to do it above here again. Yeah, so then it'll push 5, and then it'll come down here, and I won't actually change anything. So let's get rid of that one. 10. Okay, so that seems to be working. And then if we do jump main, and you push 10 there, then that should not ever be called. 5. Okay, why is that 5? Did I not rebuild? Push 5, then jump to main, push 5 again, and add. Okay, that is odd behavior. I'm going to take a quick break, and then I will be back. So yeah, give me a minute. Okay, I am back. I appreciate everyone who waited. Alright, so let's see. So, alright. So why is it 5? I'm not sure why it would be 5 ever. We are adding. Maybe I should print the stat. Alright, yeah, let's do not in here. In here, I'll print the stack of the machine. Let's build it again. Actually, we just run it directly. Okay. 5. 5. And there's a bunch more operations. Okay, so that's not very helpful. Not very helpful. So let's actually, whenever we jump, let's actually just F jump. And then we should get an idea of how the jumps are working. Jump. Alright, so 2 jumps. That should be right. But it seems to be jumping past that. So let's actually jump, and then also we'll print the jump index. Yeah, so just IP. Alright, that needs to be a LD, which means long double. Not double. You know what I mean. Alright, 3 and then 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's jumping to there. That's not where it should be jumping. 0, 1, 2, 3. So it's jumping 1 too early. But no, actually that's fine in the case of the machine. Should be. Let's see. Actually, we can try it. We take this and push and there. Does it change the output? Alright, underflow. That is quite interesting. Let's get rid of this one. Yeah, why does it underflow? So it's not, alright, let's print every time we push. Push. Alright, and we'll see what it does. So we push once. So we jump, then we push. Then when we jump to main, it's just jumping straight to add, or so it's pushing 5. Forget it of add. 6, 5. So yeah. So it's jumping straight to that. So this is gonna jump out of bounds, or yeah. Okay, so it's jumping too far. One too far. Whoops. So so we are subtracting in there. Okay. Let me close out this one. All right. So we're jumping too far. So do we have to subtract 2 from the line number? right, in here, give it a no. No. Okay. Then we push 5 and add. So, okay. But that's not right because jump 1, that should be jumping to there. So I don't quite understand. I don't understand. Ooh, okay. Actually, it's because we're iterating through the program size and it ignores white spaces. Oh shoot. So yeah, it's based on white spaces, isn't it? So if we do something like that, whoops, then it's not gonna work properly. Yeah, okay. So that's a problem. How can we deal with that? So if we that is a very big problem. So we can't base it on the line number. So we'll just have to do the current index. Can we do that? Because we have the index. So what? Yeah, what if we do that? If we just pass index into here, like that. Let's see. All right, and now we run it. All right, can I? All right, so that that can work. Because this is, yeah, we do that as a pointer. Hmm. X. And then we pass this in here. Then it will not be constrained by that. Right, index. Oh yeah. So this needs to be. Hey there, that guy Tubbs. Thank you for following. How are you doing? Okay. Let's see. So now it builds. Okay. And if we run it now, label or yeah, test slash label test slash 10. And okay, jump -1. So actually, let's look at the values that it does. So it's jump index of 0. Yes, that's not what we want. So but then that becomes 1. So that's not good. It's not what we want. So the index here so let's see. So let's actually make that index so we can see what it is. So print it 4 and then 9. So that is actually what we want, I think. Because 0, 1, 2. Maybe not. I don't know. Well, that's closer. So but it's not setting it properly. Yeah, so it has the same problem. So I think we need to mm, we do make it a global variable, and then we don't pass it in here. We do want to pass it actually. So let's call this one in. And so no, that's not gonna work. I'm gonna do it like that. So okay. Give it a that. So we're having the scope issue. Okay. What? Let's see. So this should be working now. It is. And I'm not freeing it, so it should stay the value. Um, so yeah, it's the same problem. So we really want went to Twitter to DM you, but you could not. Let me see. I think it's because you need to be mutual followers, right? I can follow you back. There you go. Yes. So I think that is the reason why. Okay. So uh hmm. Okay, well yeah, then that does that, so that's not good. That's why you want to use global variables for everything, but uh-huh. Because we don't want that, so that's not good. That is not what we want. So, okay. This needs to be a pointer. Right, that won't work now. Okay. Now it seems to be working. I swear I did it like this just a minute ago and it wasn't working. Alright, let me just make sure. Yeah. Okay, that looks good actually. Let's try 3 and then 8. Yeah, so I might need to actually subtract 1 still. Yeah, it's -1. Okay, so we have push 5. Right, and then yeah, it prints out 5. So that's not what we wanted to print out actually. Let me do it. So this shouldn't change the program. Okay. So stack underflow. Okay. Alright, let me just jump main. Yeah. Push 5. Alright, push 15. Okay, so that works. Then when we add another main here, it should never do anything. It just loops there. Yeah, so that is a thing. Okay. We're getting somewhere. Okay. Alright, let's see if that works. Okay, so that works. And then if we don't make here. Okay, and then it stops working. So we seem to be jumping 1 too far then. Still, we put a space there. Okay, so it doesn't seem to be changing. So now there's gonna be a negative though, right? Or 0. Yeah, so that's not right. Right, let's see. So jumps to 1. Alright, so that is right. And then here, jump to 6. So 0, 1, 2, 3. 4, 5. So actually, dang, the index isn't gonna work either. Because we are going through each token, and so this would count as 2. So that's not. Oh, sweet. Okay. All right, I will check that out. Okay. So I'm gonna need to do this a different way. Index. Well, so we might be able to actually do like set a value, which is like, let's see, basically line number. Kinda, not, let's see, I'll come up with a better name. And then, yeah, we can iterate through it at the end, and I think that'll work. So I can do line 95, and we can pass that as well into, let's see, it's actually down here, line num. So yeah, so we take line num, and so we can pass that as 0 as well. Okay. So no token depth. Alright, actually need to change that to an int. Maybe yeah, test. Okay, so that doesn't work. Alright, what did it generate? 0 and then 4. So 0 is not right. Alright, 1 and 5. Alright, 15. So is that what we wanted? Push that and then jump main. Okay. Now let's add like a push 5 right there. Okay. Didn't do anything. And let's add it there, push 10. And make it a different number so it's more clear. 8. So now, okay, that still works. And let's add a gap here. And we'll put push 11. Okay, so I think that is working. So let's get rid of all of this. And let's do jump main. Whoops. Jump main. And then go all the way down here. We'll have a main and we'll push 5, push 7, add, and print. Alright. Let's see. So, alright, jumps to 1 because that is the next. Alright, so that. Okay. So that seems to be working actually. And then let's make another label up here. So like test. And then we also have to make another one at the end, and we'll call it end, and it will just do nothing. And then test will push 10 and push 2, add and print, and then we'll jump to end. So that way it won't loop forever. And alright, 12. Oh, we never actually jumped to test, so okay. Let me get rid of some of this debug information that I have. So that's all in here mostly. I think I let's see. Here. Got that chasm. Alright, we can not print those now. Alright, up here. Oops. There we go. Up here, we are not printing anything. Here though, print that. Let's see. Let me actually search for it. Alright, yeah, so we can get rid of that. Okay. Label F5. Alright, and alright, we are still printing push, so let's get rid of that. Push, push. Whoops. Alright, and now, alright, run that. 10, 12, and then 12. So, alright, so they actually are both 12. So let me change that to 14. So it should be 12, then 14. Okay, 12 and 14, and then it ends. And let's actually make sure it ends properly. So let's like push 5 and then print. We'll push 2. And then stack underflow. Okay, so dang. So why would it do that just on this list? Let's look at what it generates. Dang, we can't now because I turn it off. I will do that again. Okay, so we can look at it. So here we have nope. We just actually care about the jump, and then the int afterwards is 1. Alright, and that is right. All right, let's see, jump, and then 15. So that should be this one. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So why is it so far? Oh shoot. It is probably, okay. So it's gonna be something in here. Let's see. So we don't want to, let's see. So push. Let me actually do something like that. Okay, so we don't, so it might be with the label. Let's see. So we don't actually, which one is not used? So the definition becomes a nope, a not. So after this one, actually, I think we can do just something like that. So now if you're running loops forever. Okay. Uh-huh. So if it is a label, okay. Actually, we don't want it to be a label ever, right? Okay. So yeah, we have 3 type label. So, okay. So actually in the jump, all of the jumps, we have to do a similar thing to this. So all right, and then we do that, or index.type is not equal type label, int or label. Okay, yeah, then we want to append it. So we can do basically this same thing down here. All right, and now we should not encounter the labels. All right. And I need to use and. Okay. Now let's build this and run it again. And now, let's see. Okay. Okay. So does it work like this? 2. Okay. I think it is actually working now. All right. All right. Let's do n and then jump. Real n. And it's real n here, and we'll push 15. And Yeah, I need to do that, and it can't be an underscore because that's not supported right now. Okay. So, alright, yeah, we want to actually jump this afterward. Okay. I think it's actually working now. For real. Yeah, so now we can jump real end. Yeah, yes, indeed. Let me this out again. Build it. Yeah. Then do that. Type label, we can, oh shoot, so we are encountering that still. Why are we still encountering that? Let me print the label. Let's see. Okay. Token stack index dot text. Alright, and let's see what the label is. Main. So why is it not handing that up here? Append that. Okay. Just for this one. And push. Right. Jump in. Let's see. Time, test, label 10.10. I mean, it's working. I'll need to look into it. But yes. So now, this works. This is a bit of an odd example, but I think it's fine. So yeah. So basically, it starts out, it jumps to main, which is all the way down here. Then it does that, and it will print 12. And then it jumps up to test, and then it will print 14. Then it jumps to n, it'll print 7. Then it'll jump to real n, and it'll print 15. And then it'll jump to the n, and it'll print 99. And all of those are printed here. So, yes, yes indeed. Okay, so I mean, I think that is okay, and we can use our run a test, and I remove dot anything dot thing. So now we build.sh and we use the -t flag. It'll build all the tests in here, and yes, indeed it did. So let's do test slash fib.tin, and we'll need to do this one. Okay, so that worked. And we'll now do label test.tin. There we go. Alright, so that seems to be working. I'm gonna actually move label test.asm to label.asm. Because I think that's good enough. Label test.tin. Alright, and I'll remove fib.tin. Okay. Yeah. So we now have labels in our custom assembly. That is pretty cool. Alright, so I'm gonna go ahead and push this. Implemented labels. So you can now use the jump with either an int or a label, and it will jump accordingly. Okay, and I'll push that. Okay, and it should be up here now. Alright, here we go. So I will put that in the chat. So I think that is just about it for the day. Let me just do that. Okay. Yeah, so I think I'm gonna be done. Gotta make sure everything is all good. Everything looks good in there. Let's take a test. Okay. Yeah, so thank you for watching. Next time, let me think actually. So next we should probably get floats and like basically set up the machine to support floating point numbers and operations, as well as probably like a pointer. Yeah, so I think that's what we need to do next. So stay tuned. Next time I will work on that. So thank you for watching, and I'll see you next time.